Question 10. Question 10 says, well, let's take a look at the question together. Solve the following: x dy over dx plus 2y is equal to 3. Very well. So is it separable? Is it linear? Which classification it belongs to? If we try to write it in separable form, so let us check if it is separable. So here you get x dy dx equals to 3 minus 2y. So now if you just divide by 3 minus 2y, multiply by dx, divide by x, just doing algebra. Algebra. So here, divide by 3 minus 2y and multiply by dx and divide by x. Divide by x, you get the following. You get dy over 3 minus 2y equals to dx divided by x. Is it separable? Yes, it is separable. So it means that we can just take the integral of both sides. Yes. Take the integral. Okay, let us do the calculus part. Here we get the integral of dy divided by 3 minus 2y equals to the integral dx over x. So here you can use substitution. Let u be 3 minus 2y, du is negative 2 dy. What do we get? We get negative a half ln of absolute value of 3 minus 2y equals to ln of absolute value of x plus constant of integration. Let's call it c sub 1 because you have ln. Eventually, you're going to use the definition of ln and you create a new constant and you need to rename it. So what are we going to do? Let us multiply everything by negative 2. Just doing the algebra now. Let's keep writing these this way. So if you follow which step we are in, you get ln of absolute value of 3 minus 2y equals to negative 2 ln of absolute value of x minus 2 c sub 1 or plus negative 2 times c sub 1. You can call this guy c sub 2 and bring this guy to the other side and you get ln of absolute value of 3 minus 2y plus 2 ln of absolute value of x equals to c sub 2. So we're calling this guy c sub 2. Now, using the properties of ln, you can bring this exponent, bring this coefficient as the exponent, and then since you have addition, you get ln of absolute value of 3 minus 2y times absolute value of x to the second power equals to c2. Very well. Let's see what else we can do. Here we get 3 minus 2y times x equals to plus minus e to power c sub 2. And here you can just isolate your y on one side eventually by dividing everything by x and call this guy c sub 3 or just c. Now we have, well, 3 minus 2y equals to c sub 3 divided by x. And then here you can write down 2y equals to 3 minus c sub 3 over x, or y equals to 3 halves minus c sub 3 divided by 2 over x. So your y is 3 halves, and here you can write it as plus c over x. So what are we going to do? We're just taking this guy as plus sign and put a negative sign in front of c sub 3. C sub 3 divided by 2 is a new constant. Let's call it c. So by the method of separating the dx dy's and their expressions, their functions, their coefficients, we get this general solution, and we were able to isolate y on one side, pure algebra. This is the general solution. Now, now let us check to see if it's linear or not. I'm going to copy this guy down here, and okay, this is c sub 2. I'm right, I forgot to put the exponent here. C sub 2, here, get x squared. I forgot to copy the exponent down here, so please fix that. Now let's check to see if it's linear or not. I'm going to copy down the general solution that I got using separable differential equation. So it's just y. I'm going to write this guy down here for you. So you're going to see that it doesn't matter if you apply separable method or linear method, you get the same solution. C divided by x squared by separable. Sometimes students feel more comfortable using separable methods. Some other times they feel that, okay, finding the integrating factor is much easier. So now let's check to see if it's linear or not. To be linear, we have a general definition for first order linear differential equation. It is a sub 1 x y prime plus a sub 0 x y equals to g of x. Guys, remember that this happens when y is a function of x. If we change the independent variable, or if you write x in terms of y, the whole representation will change. Okay. So what do we have here? Let's just compare these one by one. Here you have x, y prime, plus 2, y equals to 3. Just compare them accordingly. You have x, which is a term in x, the coefficient of y prime, which is just right here. And here you have a sub 0x, the coefficient of y must be a constant or in x. As you can see here, you have a constant times y, and on the right hand side you just have a constant. You have a non-homogeneous linear differential equation because this guy is not 0. So it is linear. So if we know it is linear, we can apply the method of finding the general solution for this differential equation. So linear, what is the very first step? First step is to write it in standard form. In standard form, it means that the leading coefficient of y prime must be 1. So you must have y prime plus pxy equals to qx. The leading coefficient is not 1, so we have to divide by x. So in step 1, algebra, divide by x. So y prime plus 2 over xy equals to 3 over x. We found our p of x and q of x. What's the next step? In the next step, we need to find the integrating, this is number 2, integrating factor. Okay, integrating factor. It is e to the integral px dx, which in this case is e to the integral 2 over x dx, which is e to 2 ln of absolute value of x, or it is equal to just x squared. So integrating factor is x squared. Now in step 3, we multiply everything that we have by the integrating factor. Multiply by the integrating factor, which is x squared. So let's see, we have x squared times y prime plus 2x y equals to 3x. Now in step 4, we see we have the expanded form of the product rule, so we can write it in compact form, the dx of y e2, the power integral px dx, and on the right hand side you have the multiplication of your integrating factor and whatever is on the right hand side, so we're going to use q sub 2 of x. So again, double check. On the left hand side, it is the expanded form of the product rule, all right? You have y prime times the function plus the derivative of the function, which is 2x times y. So this is dx of y x squared, and on the right hand side, you just copy down whatever is left there. Now in step, okay, so we multiply this is step 4. Now in step 5, we take the integral. Okay, take the integral. Our last step. The integral of the derivative, it results in y x squared equals to the integral of 3x dx. So y x squared is equal to 3 divided by 2 x squared plus constant of integration. Now to isolate y, divide everything by x squared. So what do you get? You get y equals to 3 halves plus c over x squared. You get the exact same general solution using the linear, first order linear differential equation method.